All right, last but not least, how do we compare distributions using histograms? So, two notes to make when using histograms to compare distributions. Number one, use relative frequencies. Again, remember, relative frequencies are percentages. Use percent because if the group sizes are different, you don't want the bars to just be the counts because the group that's larger will have taller bars. Percents level everything out. And then number two, make sure you use the same intervals when you're comparing. You want to make sure that horizontal axis is common. So don't let one group have intervals of width 5 and the other one have intervals of width 10. It's very hard to compare then. All right, so here we go. Here's our question. Example 3, why should you get your diploma? Is it true that students who graduate from high school earn more money than students who do not graduate from high school? To find out, we took a random sample of 371 U.S. residents aged 18 and older from a recent census. The education level and total personal income of each person was recorded following our relative frequency histograms of the data for the 57 non-graduates, or the no, so no, I did not graduate, and the 314 graduates, or yes. Compare the distributions. So first of all, look at these two numbers, right? 57 no's, 314 yeses. So if we were to just do frequencies and not relative frequencies, obviously the 314 graduates, we'd have to displace them higher because there's more of them. So that's why we do percentages, which is what they did right here. So notice over here, you have the same horizontal axis counting by tens. And again, these are in thousands. So each width is actually a width of 10,000, okay, dollars. And then up here, you have your no histogram and your yes histogram. So when you're comparing distributions, 4 things to look at. First is the shape. And remember, for shape, we just listed out. So for the no's, that shape is skewed to the right. Right? The peak is here, and then there's no left tail, so it's all skewed to the right. For the yes, I did graduate high school, it is also skewed to the right. Notice that there's a lot more skewness, there's a lot more higher values, but it's still skewed to the right. Then we look at center. Now, one thing to keep in mind is that when you're not using frequencies, when you're using relative frequencies, right, it's percentage based. So before we would count dots, right? So if there were 57 dots, we would count to what? The 28th dot, something like that, the middle dot. Well, because it's percentage based now, we're going to look at where is the 50th percent person, right? So if I look here, this bar already reaches 60%. So 50% is in this bar. So that is where the center of the nose is. It's in this bar. So that's kind of weird because you think it's way to the left, but that's where the center of the data is. So we're going to say nose center. And again, that just means not graduate. Nose center, which is in the interval between 0 to, and it's this first interval, and again, each interval is worth $10,000, between 0 and 10,000, is, and now this is where you must use the comparative words. Is it less than, greater than, or about the same? Well, let's find the 50th percent for the yeses. This first bar only goes up to 30%. So 50% is not in there yet. So then we go to the next bar and we say, oh, this next bar is about 20%. What is 20 plus 30? 20 plus 30 is 50%. So about the 50th percent person is right around there in this bar. Now, if you said that's a little bit less than 20, so you went to the next bar, I'd be okay with that too. But I'm going to say it's between $10,000 and $20,000. So therefore, the yeses center is higher, which means the no's center is less than the yes. Is less than yeses center. And again, yeses center is the next interval up between 10,000 and 20,000. And again, like I said, if you wanted to use between 20 and 30, that'd be okay as well. Next, the variability. So remember, the variability is just the spread ability. So how spread is the data? So nose variability, and you can use abbreviations if you want to, like VAR. Nose variability. And now we're going to take the largest value and subtract the smallest value. So the largest value, if we come down here, looks to be 60,000, and the smallest value is 0. If we subtract those, 60,000 minus 0 is 60,000. So that's how spread. Those who don't graduate from high school, that's how spread your income can be, a $60,000 range. Okay. And now obviously because the yeses extends farther, their variability is going to be more. So no's variability is less than yeses variability. And to find yeses variability, we need to take this largest value, which is 150,000, and subtract 0. Well, 150 minus 0 is 150,000. So you can see that those who graduate high school, there's a little bit more spread in terms of how much income you can make. There's more variability in what you can do with a high school degree. And then last but not least is the outliers. And when you do outliers, you just list them. So I'm going to list no first, and there are no outliers. Everything is connected, so there's none. And for the yes, I graduated high school, definitely this interval right here between 130 and 150,000. And if you want to, you could also include this one. I'll put a question mark above it. If you didn't, I wouldn't take off, or I wouldn't care. Typically, the outliers are the farthest ones, but that could also be considered an outlier because it's outside of this cluster. So we're going to put that in question mark. All right, great. So this is histograms. So very much similar to how we're doing all of these, presenting our data and comparing distributions. All right, good luck on your homework.